Okay, so question number 9. Calculate the molar mass for sodium sulfate, Na2SO4, and a sample of sodium sulfate with a mass of 300 grams represents what number of moles of sodium sulfate? This is a two-part question. So first we need to find the molar mass of sodium sulfate. And to do that, we need all the different atomic masses of the atoms involved in the compound. And we also need to take into account how many of each atom is in sodium sulfate as well. So for the molar mass, it's going to be 2 times the molar mass of sodium plus the molar mass of sulfur plus 4 times the molar mass of oxygen. So all of these molar mass values for these different elements can just be found on your periodic table. So in the case of sodium, sodium has a molar mass of 22.99 grams per mole. Sulfur has a molar mass of around 32 grams per mole. And finally, oxygen has a molar mass of around 16 grams per mole. So now if we add all these values up, we get a final molar mass of 142 grams per mole. Okay, so that's for part A, where capital M is molar mass. And when we solve for part B, we know the mass is 300 grams. What are the number of moles of this amount of sodium sulfate? So to answer this question, we'd use the equation number of moles is equal to mass over molar mass. So the mass was 300 grams. And we calculated the molar mass in the previous step to be around 142 grams per mole. So 300 divided by 142 gives us 2.11 moles. So you'll notice that when we divide mass by molar mass, our grams will cancel out and our moles becomes our unit. Okay, so now let's see what the junior tutor said. First, they calculated the molar mass of sodium sulfate. They determined the elements and how many atoms of each are involved in the compound. So there's 2 sodium atoms, 1 sulfur atom, and 4 oxygen atoms. Step 2 was to determine the mass contribution by each element by its molar mass with the number of atoms there are. So they summed up all the different molar masses of the elements, and then they multiplied it by however many atoms there are. 23 times 2, 46. 32 times 1 is 32. 16 times 4 is 64. Step 3, add the mass contribution of each element to determine the molar mass. So 46 plus 32 plus 64 is 142. So they did it in multiple steps. I just fit all of mine on one line. But if you like to show all the different steps, then you still get the same answer, which is good. And then a sample of sodium sulfate with a mass of 300 grams represents what number of moles of sodium sulfate? So to determine how many moles there are, divide the given mass of sodium sulfate with its molar mass. So 300 divided by 142 is 2.11 moles. Yep, so this solution is correct. Great explanation.